mentioned, I am here to give you the graphing part of the video. And the graphing here is we're just going to kind of look at the exponential compared to the logarithmic graph. So if I started with 2 to the x power, we know from previous lesson that 2 to the x power looks like this. And we have very specific points. We have the point 0, 1. We have the point 1, 2. And we got these the other day with just plugging in numbers. It's -1. Makes this a -1, 1/2. We're just going to basically use those 3 points to help us out for the graph. Well, we remember we got our horizontal asymptote for the exponential. Now, for the logarithmic, we are just going to swap x's and y's because that's really what we did when we found inverses before. So if I create a new xy axis, and just started swapping points. Instead of a horizontal asymptote at 0, we have a vertical asymptote at 0. Instead of the point 0, 1, we have the point 1, 0. And then so on and so forth for other points. The point 1, 2 becomes the point 2, 1. This point, -1, 1/2, becomes the point 1/2, -1. And if you kind of kept doing the points, you'll notice that the graph follows basically the same curve, but you notice that it reflects across the line y equals x. And it actually does, even the way I have it oriented, it looks like a reflection. This going up to the right, this going up to the right, but it looks like it's reflected across some line right here in the middle, which it actually is. Okay. All right, so this is log base 2 of x because this was exponential base 2. Okay. What kind of goes right along with this is, I mean, any of the other bases. So if I wanted log base 3 of x, okay, I would initially think about what is 3 to the x. Well, I know 3 to the x, and I'm just kind of thinking about it this way. I'm just going in my head. I'm saying, okay, if I had -1, 0, and 1. If I plugged in -1, I get 1/3. If I plug in 0, I get 1. If I plug in 1, I get 3. Well, on the logarithmic graph, it's just the switching of the x and y's. So I can say, okay, 0.13 should be the 0.31. 0.01 should be the 0.10. And the point -1, 1/3 should be 1/3, -1. Most of the other points, they just don't even fit on my graph anymore. But again, you notice this same basic shape for a logarithmic function. And we have our vertical asymptote still as a guideline. And some of you might be thinking, well, what about transformations? Well, what about them? They do the same thing as we've always done them. So if I said this is for transformations, if I did the transformations, let's just say I had the log, let's just go log base 2 because we already have what log base 2 looks like right up here above it. Let's say log base 2 of x minus, let's go 2, just x minus 2. Let's go x plus 2. It's an easy change. Well, we know that the plus 2 on the inside of a function moves it left 2 units. We just know that. We should know that. If you don't know that, go back and refresh yourself from one of our sections of chapter 2, or even chapter 1, I think. Well, one of the first things that I like to move is the asymptotes. So this vertical asymptote that's usually at 0 gets moved 2 units to the left as well. That point that usually was at 1, 0, and if you're looking at the graph up above, the point 1, 0 becomes the point -1, 0 by moving 2 units to the left. And likewise for all of our other points, the point 2, 1 becomes the point 0, 1. This point at the half becomes -1 1/2. And we get our sketch thusly. Okay. So the big thing for transformations is just kind of think about what did the original graph look like, what transformations are occurring, and we know them all already. We already know how to deal with transformations. Um, the one thing you guys do have to remember is that kind of gets lost is if I said log base 2 of 2 minus x. This came up one of our problems for exponentials in the last lesson, and there's two ways. I don't know why I wrote two ways there. I said it. But way number one is, and this is an order thing. It's not like you know what happens to this function, but there's an order to it. The first way is saying, okay, this is a positive 2, which means I moved left 2 units. And then the key word here, then. I moved left 2 units, then the negative x is actually a reflection over the y-axis. That's what the negative x does. So that's way number one. Way number two is to think about this logarithm in a slightly different manner. This is actually log base 2 of negative x minus 2. Notice those two things are still the same thing. You can verify for that for yourself, just kind of thinking about distribution. If you think about it in this manner, you actually have to reflect first. It's still a reflection over the y because it's changing the x values. And then again, that key word, that super hard word that I hope everybody can spell correctly. This is not the than. It's not T-H-A-N. It's T-H-E-N. Okay. It's reflecting over the y-axis. Then this minus 2 means right 2 units. And you should graph this on your calculator, see what happens here, see what it's going to look like. It will end up looking a little bit something like, I believe, right 2, so asymptote there, and something along this line, I believe, if I did this correctly in the top of my head, should look something like that. All right? So that was actually the entire piece that I needed to show on my example list here, how to graph logarithms, and I will give you graph paper for your problems that are due to me on Monday. I hope this little example video wasn't too long for you on addition to the other video, but I think it was useful. So there you go. Have fun. Good luck. See you guys on Monday.